Hello students, and once again welcome to Pankaj's Echelon Tutorials, and this is lecture number 2, or you can say part 2 of our IGCSE chemistry that we have started last time. So we are dealing with IGCSE curriculum. The subject is chemistry, subject code is 0620. Name of the chapter is electrochemistry. This is chapter number 5th from the book Hodder's course book, the 4th edition. Okay, so in the first lecture, I had just given you the introduction of what is electrochemistry, and there I tried to explain you that electrochemistry is nothing but a relationship between the chemical reactions and the electricity. Okay, so whenever there is some particular type of chemical reaction taking place, and these chemical reactions are known as redox reactions. Okay, so whenever there is a redox reaction taking place, okay, there is electricity generated. Okay, and that is the connection, and the reverse of this is also true. When you pass electric current, then only certain redox reaction can take place. Okay, otherwise they won't be able to take place. So that was a relationship between chemical reaction and the electricity, and this relationship we developed because of the fact that electricity is nothing but it is a result of moving electrons, and in redox reaction actually the electrons are moving from one atom to another atom. Okay, so in both the cases there's a movement of electron taking place, so electricity has to be generated in both the cases. So that was what we talked about in the first lecture. Then in the first lecture we also talked about what is a process called electrolysis. So electrolysis was a is a process in which the electric current is passed through an electrolyte, and that electrolyte is decomposed into its respective ion. Okay, and these ions, when they start moving, they constitute a electric current. Okay, so that was electrolysis ka process. And then we studied about the terminology of electrolysis. So what are the terms we studied? We studied what is an electrolytic cell, then we studied what is electrolysis as a process, then we studied what are electrodes, what are electrolytes. In electrolytes we have something called electrolytes and non-electrolytes. Okay, and then we studied what is cathode and what is anode. These are the two types of electrodes. Then we studied what are the two types of ions formed from the electrolytes. So the two types of ions formed are cations and anions. Cations are one which have positive charge, anions are one which have negative charge. Then these are the terms we studied in this electrolysis, and then we started with what is electrolysis, how it takes place, and I ended up the first lecture with a note that in the second lecture I'll be taking an example of actual electrolysis process taking place, and I'll be explaining you electrolysis process from that example only. Okay, so today being lecture 2, I'll be starting with one example, but before I start with the example, let me tell you, in the lecture number 1 I talked to you about something called electrochemical series, okay, which was very important, right? And there I told you that electrochemical series, you need not try to understand that electrochemical series more in detail. Okay, only what is required for your curriculum, that much you should know. Okay, so today I'm going to start with this electrochemical series, what is precisely required by these IGCSE students. Okay, and then I'll proceed with one example. Okay, and that example will be of lead bromide. Okay, so today's session I'm starting with this electrochemical series, that is ECS. So what is this electrochemical series? ECS is the abbreviation of that electrochemical series. Now in the last lecture I told you electrochemical series is nothing but an arrangement of certain elements in a particular order. So if you take H over here, okay, and if you write like lead, okay, and then Fe. Now some of the elements, I'll be missing out. There are many in between also, but I'm writing the main ones. Okay, so this is hydrogen. Above that I'm writing lead, and then Fe, and then zinc, Zn. Then I'm writing aluminium, Al. Then I'm writing Mg, magnesium. Okay. Then I'm writing sodium and calcium. and potassium. Okay, so these are the elements which I am writing above hydrogen, and below hydrogen I want to write it as copper, Cu, Hg, that is mercury, and Ag, that is silver. Now this particular uh, elements that I have written, okay, with reference to H. So there are some elements above H I have placed and some elements below H I have placed. Okay, so H is the reference. Now these elements are known as electrochemical series of anions, cations. Okay. So this is the electrochemical series of cations. Cations means positively charged ions. Okay. So you can see these elements. Now what these elements, what this electrochemical series is indicating is it is in the increasing order. If you go from bottom to top, okay, if you go from bottom to top in this direction, what is happening, I'll tell you. Okay, if you go from bottom to top, okay, the ease with which the elements are going to lose their electrons, is going to increase. Okay, so this from top bottom to top, what is happening, the electrons the electrons lost is more easy. Okay, electron loss is more easy. I should write not lost, should be electron loss. Okay, what I mean to say is, in comparison to copper, okay, the hydrogen, will be losing electron more easily, and in comparison to copper, zinc will be losing electron more easily. Okay? So the element which is at a higher place in this series, okay, at a upper position, okay, will be losing electron more easily compared to the element in the lower position. So if you take this zinc and copper, between zinc and copper, you can say that zinc is a atom which will lose electron more easily compared to copper, because zinc is placed at a higher level from copper in this series. Okay, so from bottom to top you have to see. So the electron loss, is more and more easy when you go from bottom to top. That is the meaning of it. Now the ultimate connection is this: when the electron loss is more easy, okay, the loss of electron is more easy. Now loss of electron from the metal, okay, all these are metals, right? So the loss of electron from the metal, if it is more easy, okay, then this indicates that whatever cations will be formed from this. Now suppose I'll give you one example. Suppose you have magnesium, okay. Now this magnesium will lose 2 electrons because it has 2 electrons in the outermost orbit. It will lose 2 electrons to give you magnesium ion, okay, and it will have a 2 positive charge. So this magnesium 2 positive charge is known as a cation. Cations are ones which are having positive charge. Okay, so can you see this magnesium, it is losing 2 electrons to form magnesium ion. Okay, and this magnesium ion is known as a cation. Now whenever this is happening, the magnesium is over here in this position. Okay, so you can say that because it is at a higher position, okay, the electron will be lost more easily. But the thing is, electron loss more easily also implies that this ion which is formed, okay, from that magnesium, that is Mg2 plus, okay, this will now, be this cation will be finding it more difficult. Okay, so this Mg2 plus is more difficult, okay, to gain electrons. Okay, to gain electrons, this is the meaning. Okay, so if a metal is losing electron easily, then whatever ion will be formed as a result, that ion will find it equally difficult to gain electron later on. Okay, so gaining the electron later on becomes more difficult for those atoms, okay, for those ions which are formed from the elements where the electron loss was more easy. Okay, So if you understand this relationship, you will understand this working of this electrochemical series. Okay, so when the electron loss, let me write that for you. When you have a metal, okay, and the loss of electron is, say, easy, loss of electrons is easy, suppose. Okay, then what will happen? Positive ions will be formed. Okay, that is cation will be formed. Cation is formed. Okay, that is okay. Now along with this, what will happen, this cation which is formed, okay, it will be finding it more difficult to gain electron. So gain of electron by this cation will be is more difficult. Okay, so this you should remember. This is what is happening. Got it? Now the opposite of this is also true. Suppose you have a metal, and suppose the loss of electron is difficult, or you can say is not easy. Is not easy. Okay, metals say loss of electron is not easy. Of course it is not easy, but then cation will be formed. Now this cation, okay, will find easy to gain electron. So gain of electron will be easy. Okay, gain of electron will be easy. If you understand this logic, then electrochemical series, how you have to use it, will become very easy for you. Okay, so that was about this electrochemical series that I wanted to tell you. If you understand this concept, it's well and good. And now I'll take an example of now this electrochemical series plays role when there's a competition between two types of cations, okay, trying to reach the cathode. Okay, out of these two, any one has to reach the cathode. Okay, not both, right? So which is going to reach, that this electrochemical series is going to help us in deciding. Okay, so that we will come back to that particular point when we do that particular example. So that was something about this electrochemical series that I wanted to tell you. And let me tell you, even for this was the electrochemical series for the cations. Same way you have electrochemical series for anions also. Okay, anions also you may find more than two anions. Okay, two or more than two anions. Okay, in the electrolyte. So in the alliance also there can be the competition of reaching the anode. Okay, so in the anions, the order of the series is you have to start from OH as the bottom. Okay, and if you go on the top from OH, you have to come to iodine, then bromine. All these are 1 minus. Okay, bromine, then chlorine, 1 minus, then nitrate, 1 minus, and then sulfate, 2 minus. Okay, again here going from bottom to top. Okay, going from bottom to top, the ease with which these ions are going to accept the electrons. Okay, these ions will have to now these ions will have to give away electron. Okay, to become neutral, they will have to give away electron to the anode. Okay, so the ease with which this ions will be giving away these electrons, will be in this order from bottom to top. It will increase. Okay, and the same logic will apply if the more easily it is able to give away the electrons, that much difficult it will be for them to reach the anode. Okay, so reaching the anode will be most difficult for uh, the species which are on the top. Okay, reaching the anode will be difficult for these species which are at the top of OH. And here in the anions, it will be difficult for this top elements, okay, to reach the cathode. So this potassium, calcium, sodium, these are the elements, okay, whose ions will find it difficult to reach the cathode. Okay, so when there is a competition, the upper one will lose the battle compared to the lower one. That way you can understand. In the case of cations, and in the anions also, the same logic you have to apply. The upper ones will lose the battle in comparison to the lower ones in reaching the anode. Is that clear? With this as the background, let us start with a very first example of your book, and it says that it's 5.2, okay? And he's talking about electrolysis of uh, lead bromide, okay? Lead to bromide, okay? Lead to bromide, the formula will be lead is Pb, and because it is 2, valency will be 2, so it will be PbBr2. Okay, this is lead to bromide. Now this you have to take in a molten state. Okay, in a molten state. Now let us try to understand and study this electrolysis of lead bromide in the molten state. Fine. So if you want to carry out this electrolysis of lead bromide in the molten state, what you have to do is you will have to take one container. Okay. In that container, you will take, first you take solid lead bromide. Okay, you take solid lead bromide, PbBr2. Now you dip two electrodes. Now suppose the two electrodes are carbon. Okay, this is also carbon, this is also carbon, but this is connected to positive and this is connected to negative. Okay, so this carbon is cathode because it is connected to negative, and this carbon electrode is anode because it is connected to positive. Is that clear? Now between these two you can also try to connect a lamp or a bulb sort of thing. Okay? Connect the bulb between these two. Now what will happen? The bulb is not going to light. Why? Obviously it is not going to light because there's no current flowing through this. Okay, this closed circuit, there's no current flowing. Why current is not flowing? Because this lead bromide is in the solid state. The lead and the bromine ions are not separated. Okay, so when they are not separated, they are not going to move, and when they are not moving, then how the electricity is going to be conducted? Because electricity is conducted only when there is a movement of some charge. Okay, so there's no charge only created, charge particles only created, then there's no question of electricity being generated, and that's the reason this bulb will not be lighted. But now suppose I somehow heat, or I pass I do something and I see that this lead bromide is molten. Okay. Molten means what? Now this lead bromide PbBr2, it will be decomposed. When you melt it, it will be decomposed, and it will be decomposed into what? It will decompose into lead ions 2 plus and bromine ions Br minus. Is that clear? Right? So lead has 2 positive charge, bromine has 1 positive charge. So this is what is known as the decomposition reaction that takes place on melting it. Got it? On decomposition, when you get lead 2 plus and bromine ions, okay, this is known as, because it is positive, these are known as cations, and these are known as anions because this is negative charge. And we have studied that negative charge ions are known as anions, and positive charge ions are known as cations. So Pb2 plus is cation, Br minus is anion. Right? So what happens is, in this molten state, now you have Pb2 plus and you have bromine 1 minus. You have many, I have just written 2 of them, but there are many lead ions and many bromine ions. Okay, now what will happen is, this particular thing is connected to a battery, right? This cathode and anode, the 2 electrodes are connected to the battery. Okay, so the current is passing, right? Now when the current is passing, what will happen is, the this breaking or the decomposition takes place. Okay, now after decomposition, these two ions are formed. Now what will happen at the cathode? At the cathode, what will happen? Now cathode is something which is connected to the negative terminal, so it will have negative uh, charge towards it. Okay, cathode will have negative charge, it will be full of negative charge because it is connected to the negative terminal. Okay, and this cathode being negative, full of negative charge, it will try to attract the positive charge. Okay, so at cathode what will happen, you know, these cations will be attracted for a simple reason that opposite charge attract each other. So cations will be attracted towards the cathode. Okay, now which is the cation in this case? It is lead, Pb2 plus. This is the cation. So this will move towards the cathode and ultimately it will reach near the cathode. And at the cathode what will happen is, now cathode, as I told you, it is full of electron, it is ready to give its electron. So this lead 2 plus will accept electrons. How many electrons? It will accept 2 electrons. From where? From the cathode. And it will get converted into lead solid metal. Okay, because after accepting electrons, 2 electrons are going to nullify this 2 plus charge of the lead ion, and this cation will now be converted into a lead solid metal. Okay, this way there are so many lead ions, lead cations, and there are so many electrons coming from the cathode, and they will be doing this job, and slowly, you know, this lead metal will start accumulating layer wise slowly on this cathode. So at the cathode, the product formed is lead metal. That clear? It is brown color metal, brownish color. So the observation is the cathode will, you will see that there is a brownish layer being accumulated on this cathode. Okay, so that is the observation. And if they ask you what is the product formed at the cathode, your answer should be the product formed at the cathode is lead metal. Okay, this brownish color layer that you see forming on the cathode is because of this lead accumulation. Okay, so the product is lead metal and the observation is a brownish layer is deposited on the cathode. Now this is what is happening at the cathode. So at cathode what is happening, these ions are taking up the electrons. Now in your previous class, you know, in your previous chapter, you have studied oxidation and reduction, right? So this lead ion is taking this electron, so it is gain of electron. Okay, and you have studied gain of electron. How we write that? Reduction is loss and oxidation is gain. Okay, oxidation is loss of electron. Okay, oil, and reduction is gain of electron, rig. Okay, so here what is happening is this lead ion, that is this cation, is taking electrons, it is accepting electron from the cathode, so it is gaining electron. So by lead 2 plus is gaining electron, so gaining electron is nothing but reduction. See here I have written reduction is gaining electrons. Rig means reduction is gaining electrons, and here this is happening. So here at the cathode you can say that reduction is taking place. Reduction is taking place, right? Now this is also known as half reaction, half cell reaction, because whatever is happening at the cathode is known as half cell reaction, and another half cell reaction will be what is happening at the anode. So fine, at the cathode this is happening and you are getting this lead accumulated. Okay, now let us check out what is happening at the anode. Now at the anode is also a carbon electrode, and it is connected to the positive terminal, so you will have lot of positive charge at anode. Okay, because it is connected to positive terminal, obviously it will have positive charge. Now this positive charge will always attract negative charge, and what is negative charge? Here in the electrolyte the negative charge is bromine, Br. Okay, Now, bromine is for the element that we use, bromine word. But if it is in ion state, we use the word bromide. Okay. So at the anode, what will happen? Because anode is positively charged, it will attract negatively charged bromide ion. So bromide ion, you have to write in this way. Okay, bromide ion, one negative charge. Now this bromide ion is going to come near the anode, and what it will do, it will give away its electron. Okay, it will give away its electron. Okay, so I'll write minus. It will give away one electron to get converted into bromine, bromine atom. Okay? Now we want that there should be one more. Now imagine this is one bromide ion giving away one electron at the anode and getting converted into bromine atom. Suppose there's one more bromide ion that is also coming near the anode and it is also losing one electron and getting converted into bromine. Now, if you add these two reactions, you can write this as two bromide ions will lose two electrons to form Br and Br, that is Br2. Now this Br2 is nothing but bromine. Okay. So at the anode, what is happening? This bromide ion, that is bromide is a negative ion. So negative ion are known as anions. So anion is going to lose electron, and losing electron is what? Oxidation, OIL. Oxidation is loss of electron. So here what is happening? This bromide ion is losing electron. So here oxidation is taking place. Oxidation is taking place. Where? At the anode. And in the process, the electrons are being lost to the anode and bromine is getting accumulated. Okay, bromine is being formed and it is coming. Now what will be the observation? Because bromine is being formed, you will see bromine is brownish, brown color ka fume. Okay, brownish fumes or bubbles, you can say, because it is gas. No, the brown bubbles you will be able to see near the anode. Okay, so what is the observation? The observation is you will see brown bubbles at the anode. And what is the product? The product is nothing but the bromine gas. Okay, so product is bromine gas. Now mind here, you have to don't write this as bromide. Okay, the product is bromine, the element is bromine. Okay, the ion will be bromide. Okay, ion will be bromide, but the element will be bromine. We are getting Br2 element. Okay, so it is bromine, it's a gas. So you have to write the product as bromine. So now we have understood the electrolysis of this lead bromide in a molten stage. I'll summarize it once again quickly. What happens is, in the molten state, this lead bromide, solid lead bromide, will be splitting into lead ion and bromide ion. Okay, this lead ion being positively charged will be attracted by the cathode. So at the cathode, what will happen? This bromide ion, which is carrying positive charge, will go to the cathode, and from the cathode, because cathode is full of electrons, okay, it is negatively charged. So these electrons will be taken away by this lead ion. Okay. So when it is accepting electron, what is happening is reduction. Okay, gain of electron is reduction. So reduction is taking place at the cathode, and as a result, you see that lead is being accumulated on the cathode. Okay. So the product formed at the cathode is lead metal, and the observation is brown layer of a metal is seen on the cathode. Similarly, at the anode, the bromide ion is traveling towards the anode because anode is positively charged and bromide ion is negatively charged. So bromide will move towards the anode, and this bromide ion will lose one electron to the anode. It will give away one electron to the anode, and after giving that electron, it will get converted into bromine. Okay. So this reaction, if you combine these two, you will get two bromide ions will lose two electrons each. Okay, I mean one electron each. So two bromide ion will lose two electrons, and two bromine atom will be formed, which will combine together to form bromine gas, Br2. Okay, bromine is a diatomic molecule, so Br2 will be formed, and that is bromine. So the product form will be brownish fumes. You will be, or the observation will be brownish fumes you will see at the anode, bubbles in the form of bubbles, and the product at the anode is nothing but the bromine gas, or just bromine. Okay, and this here at the anode, because there is a loss of electron taking place. Okay, so electron is being lost. Okay, so the process is oxidation, and these are known as the two halves. So this is known as the half cell reaction. This is half cell reaction at the cathode, and this is another half cell reaction at the anode, cathode. Okay, sorry, anode. Half cell reaction at anode. Okay, so in one half cell, reduction takes place, in another half cell oxidation takes place. This is how the electrolysis of this lead bromide in a molten state can be understood and can be explained. So in the next lecture, I'll be giving you one more example of electrolysis where slightly the things will be different, but that will be in the next lecture. In this lecture, I want to wind up this lecture here and here itself. Okay, so if you happen to like my video, please subscribe my channel and press the bell button as well, and see you in the next video with one more example of electrolysis. So goodbye till then. Take care, all of you.